Now let's see few questions based on exterior angle property. So in this question, exterior angles can be formed for a triangle in many ways. Three of them are shown here. As we can see here, three figures are given. So these three figures are representing three ways to form an exterior angles, and we have to tell how many other ways are possible and which of them, and we have to draw their rough sketches. First of all, let's name these triangles. Let's say this is A and this is B, C. These are three same triangles, so they all are A, B, C. Now as we can see here, first of all, exterior angle was formed at vertex C, and in the second figure also exterior angle is formed at vertex C, and then an exterior angle is formed at vertex B. So here we have seen two of the exterior angles are on vertex C. Can we have any other exterior angle on vertex C? No. On one vertex we can have at most two exterior angles. Now one for B is already given. So let's do one thing. Let's make one exterior angle for B itself. So this time CB was extended. Now what we can do? We can extend AB also. Let's see here. Suppose we are having this triangle. What we can do? We can extend this side now. Now we are having this as triangle A, B, C. Now one more exterior angle at B is formed, that is this angle. Can we have any other exterior angle at vertex B? Is it possible? No, it is not possible, because at one vertex we can have at most two exterior angles. Now we got two exterior angles for C, two exterior angles for B. Similarly, we can have two more exterior angles for A as well. So let's draw them. So let's take triangle ABC, which is this triangle. Now let's extend this BA. So now one exterior angle is formed here at A, and that is this angle. This time we extended BA. Can we extend CA also? Yes, we can do that. So let's extend CA this time. So triangle will be like this. Now this is triangle ABC. We have to extend CA, that is this side, like this. Now the exterior angle formed will be this angle. So now at A also we are having two exterior angles. So these are the three more ways for forming a exterior angle for a given triangle. So in total, in 6 ways, an exterior angle can be formed for a triangle. Now the next question is, are the exterior angles formed at each vertex of a triangle equal? So what do you think? Exterior angles formed at different vertices, are they equal? Let's check it out. Let's say we are having a triangle like this now. Now this is a triangle. We can name it as triangle ABC. And let's say this angle is of 80 degrees. This one is of 60 degrees. And this one is of 40 degrees. Now let's try to find two exterior angles. For that, first we have to form two exterior angles. Let's form one exterior angle at C and the second one at B. So now we got two exterior angles, which are, one is this one and the second one is this angle. Now what can we say about exterior angle C? So here exterior angle C will be equal to sum of opposite interior angles. By exterior angle property we can say that now exterior angle C is equal to 80 degrees plus 60 degrees, and this is equal to 140 degrees. Now let's do one thing. Let's find exterior angle B in the same way. Now this will be equal to sum of opposite interior angles. It means it is equal to 80 degrees plus 40 degrees. Now this is equal to 120 degrees, and we know 140 is not equal to 120. Hence answer to this question will be no, because we have seen that exterior angles formed at each vertex are not equal. Now the next question is, what can you say about the sum of an exterior angle of a triangle and its adjacent interior angle? What can we say about sum of these two angles? Let's check it out. For that, let's draw a triangle first. Now let's say we are having this triangle and we can extend one of its side like this. So here the triangle is triangle ABC, and the side BC is extended. Let's say this is point D. Now the exterior angle formed here is this angle, and which will be the adjacent interior angle to this exterior angle? See, these two angles are opposite interior angles. We know angle A and angle B are opposite interior angles. So which will be the adjacent angle? This angle C is the adjacent angle to this exterior angle. Now what about their sum? First tell me what kind of angles they are. See here, they are having a common vertex and they are having a common arm, and their uncommon arms are opposite rays, as we can see here. They are forming a straight line. So their sum will be equal to 180, as they are forming a linear pair. So it means we can write this as exterior angle, or we can write exterior angle C plus angle C. By angle C we mean the interior angle of triangle ABC. Now here exterior angle C plus angle C is equal to 180 degrees, as we have seen here. Same will be the case for other two vertices also. Therefore we can say that an exterior angle and its adjacent interior angle are supplementary. So we can write answer to this question as 180 degrees. This sum is 180 degrees. Now the next question is, a figure is given to us, we have to find the value of x here. How we can do that? What we have just studied, we have studied exterior angle property, and here one of the exterior angle is given as 110 degrees. Now what was the exterior angle property? It was an exterior angle of a triangle is equal to sum of its opposite interior angles. So here also we can use that, so which will give us 110 degrees is equal to 50 degrees plus x. Now from here can we find value of x? Yes, we can do that. Now what we can do, we can transpose this 50 on the left side of the equation. So this will give us 110 degrees minus 50 degrees is equal to x. Now by simplifying this, we will get x is equal to 60 degrees. Therefore the value of x for this question will be 60 degrees. Now the next question is, what can you say about each of the interior opposite angles when the exterior angle is a right angle? What if an exterior angle is right angle? Let's see it. For that we have to draw a triangle first, which is a right angle itself. Now we are having this triangle and we have to extend this side now. Now the exterior angle formed here will be 90 degrees. This exterior angle is of 90 degrees, that is, it is a 90 degrees angles, or it is a right angle. Now what can we say about opposite interior angles? What about these two angles? What kind of angles they have to be? Can any of them be a right angle? Will it be possible for a triangle to have two right angles? Because one of the right angle will be this angle. Angle ABC is right angle. Can angle A or angle C be a right angle? No, it is not possible, because in a triangle there can't be more than one right angles. So can any of them be obtuse angle? No, they can't be obtuse angle also, because one of the angle is already 90. If there will be an angle which is greater than 90, then the sum of all the angles will be greater than 180, and that won't be possible. Now what about this angle? So we are left with only one kind of angles, and they are acute angles. So here both the interior angles have to be acute angles. So we can write it here, acute angles. Now let's check for the second one, and let's take the same triangle for this one. Here we need an exterior angle to be an obtuse angle. So what we can do, we can extend the side BC. Now this angle is the obtuse angle. The angle formed here, the exterior angle, it is obtuse angle this time now. Now what can we say about interior opposite angles? Here we are having one of the angle as acute angle and one of the angle as right angle. So will it be the condition every time? No. We can have both the angles as acute angles also. Let's see one more triangle for that. Let's say we are having this triangle now, in which every angle is acute angle. This angle is acute, this is acute, and this is also acute. Now let's take the exterior angle at this vertex, which will be this angle. Now what can we say about interior opposite angles? They both are acute this time. We have noticed one thing, in the previous one also one of the angle was acute, and here both the angles are acute. That was right angle triangle, and here we have taken acute angle triangle, as all the angles are acute angles here. Now let's do one thing, let's take one obtuse angle triangle. So it will be like this. Now this is the obtuse angle. Let's take exterior angle as this angle. Now what can we say about interior opposite angles? As we can see here, one of the angle is acute and one of the angle is obtuse. So what we have seen in all the three cases, that one of the angle is acute angle always, and one can be either acute, right, or obtuse angle. We don't have any kind of restriction for the second angle. So for this we can say one angle has to be acute angle and the other one can be right, acute, or obtuse angle. So it means if an exterior angle is obtuse angle, then the interior opposite angles will have one of the angle as acute angle and the second one can be either right angle or acute angle or obtuse angle, as we have seen all the three cases just now. Now here it is given, if the exterior angle is acute angle, what can we say about interior angles? Let's check it out. Now let's draw a triangle first in which the exterior angle is acute angle. It will be possible only if the adjacent interior angle is obtuse angle. So it means we need one obtuse angled triangle. Let's say we are having this as obtuse angled triangle. Now which angle will be the obtuse angle? Here this angle is the obtuse angle, as we can mark it here. This is obtuse angle. So acute angle or the exterior acute angle will be this angle. Now this angle formed here is exterior angle and it is acute angle. Now what can we say about interior opposite angles? What about these two angles? Now consider the triangle. Here one of the angle is obtuse angle. So other two angles have to be acute angle only. They can't be obtuse, they can't be right angle. So here we have only one condition, that the interior opposite angles have to be acute angle only. So answer to this question will be acute angle. Now the next question is, can the exterior angle of a triangle be a straight angle? What do you think? Is it possible that an exterior angle is straight angle, that is it measures 180 degrees? So let's assume that if possible an exterior angle is equal to 180 degrees. So we can assume, if possible, let an exterior angle is equal to 180 degrees. So here we have assumed that one of the exterior angle of a triangle is 180 degrees. Now what can we say about interior adjacent angle to this exterior angle? It will be adjacent with this and it will be in linear pair with this angle. So let the adjacent interior angle be y. So here we have assumed that adjacent interior angle is y. Now what we are having, this 180 degrees or the exterior angle and this interior angle will form a linear pair. So it means we are going to get 180 degrees plus y is equal to 180 degrees, because if angles form a linear pair, it means they are supplementary, that is their sum is 180. So now from here we will get y is equal to 180 degrees minus 180 degrees. Now this gives us y is equal to 0. So this implies that interior angle of a triangle is 0 degrees. Is it a possible? Is it possible for a triangle to have one of the angle as 0 degrees? No, it is not possible. So it means our assumption was wrong. Therefore, a triangle cannot have an exterior angle to be a straight angle. So it means answer to this question will be no. Now the next question is, an exterior angle of a triangle is of measure 70 degrees and one of its interior opposite angle is of measure 25 degrees. Find the measure of the other interior opposite angles. So here we can assume, let the second interior opposite angle be x. So the second interior opposite angle is x now. Now we can use exterior angle property here, which is an exterior angle is equal to the sum of opposite interior angles. So it means we will get 70 degrees, this is exterior angle, is equal to 25 degrees plus x, which is sum of interior opposite angles. Now from here we can get 70 degrees minus 25 degrees is equal to x. Now by simplifying we will get x is equal to 45 degrees. So the final answer for this question will be 45 degrees. The next question is, the two interior opposite angles of an exterior angle of a triangle are 60 degrees and 80 degrees. Find the measure of the exterior angle. So here the opposite interior angles are already given to us as 60 degrees and 80 degrees. We have to find measure of exterior angle. Now by exterior angle sum property we know that exterior angle is equal to sum of opposite interior angles. So it means this exterior angle is equal to 60 degrees plus 80 degrees, and this will give us 140 degrees. Hence, the exterior angle will be 140 degrees. So the answer to this question will be 140 degrees. So which property we have used here? We have used exterior angle sum property, or we can simply say exterior angle property. Now in this question we have to tell, is there anything wrong in this diagram? So what do you think? Is it fine or there is some mistake in this? So let's find it out. What is the exterior angle shown here? It is 50 degrees. So we can write it. Exterior angle is equal to 50 degrees. Now what about opposite interior angles? They are 50 each. So it means sum of opposite interior angles. The sum will be equal to 50 plus 50. Now this is 100. So now what do you think? Is it fine? No, it is not fine, because here exterior angle is not equal to the sum of opposite interior angles. So it means this diagram is not fine. And what is wrong here? The thing which is wrong is the exterior angle marked here is not 50 degrees. It should be 100 degrees, or the interior angles should be 25 degrees each. So what we can write here, exterior angle property is not satisfied. So here this exterior angle property is not satisfied. That's why the figure given here is not correct.